We're live. We're not live yet. 10, 9, 8.
So good morning, everybody. Well, it's time. We'll start. Yeah, I see myself as well. Good morning, everybody. Welcome. Welcome to this joint webinar of 3 different organizations: the OI4 Alliance, UReason, and Focus On. And today we will take you with us in the philosophy of the OI4, the agreements made there, and how to implement that not on a global level and also plant level, but also on a loop level and all the way down also in device level. So Ekrem Yigitdoel will start with his presentation. He's currently in Germany, so we will have to switch screens, but that will be automated from our side. And he will tell you a little bit more about the OI4 Alliance and what the goal is of the OI4 Alliance, and that's open sharing data information. After Ekrem, Jules will kick in with his presentation, and what Ekrem showed on a global level, plant level, Jules will actually visualize for you on a plant level and loop level, how to get data from all those devices to those northbound laying systems. And I will end up the presentation on how we integrated the OI4 methodology even into the device. And it will all come back together after my presentation in a demo that UReason will be doing on what we did here together with a lot of partners here at the Duurzaamheidsfabriek in Dordrecht. So that's the 3rd location where we will be presenting from, where we actually show how it works in a demo environment, in a control loop, actually running with liquid through a pipe. So I would like to introduce Ekrem right now. Ekrem, I would like to give the word to you so you can start with your presentation.
Yeah, thank you very much, Eelco. I hope everybody can hear me and see me. As said, I'm today in Germany. And before I start with my presentation, I would like to introduce myself. My name is Ekrem Yigitdoel. I'm the Managing Director of the Open Industry 4.0 Alliance. And I'm today sharing with you, as already said, the overall idea and philosophy of an implementation alliance. So let me also share my slides with you. So perfect. So what does it mean to be an user group? So the Open Industry 4.0 Alliance is existing now almost since 3 years. So we started 3 years back around the Hanover Fair time. And we said at that time, we want to be the organization who is supporting the facilities who are running machineries with open and interoperable solutions. So a user group needs to work on implementations. So some KPIs, some figures for the Alliance itself, let me quickly share with you. So I'm one of the 2 employees. So you see here a small figure with 2 employees, but you see on the other hand, 280 plus volunteers. So that is what we call the community. So we have a community platform where all active members have access to and also contribute to the different work groups. I will share with you later on a little bit more insights about the Alliance itself. So we are above 90 members. Also that will be visible in a few seconds. And to do all the implementations, what we see as the big value of such an organization, we have several work groups, in total 17. Also here I will share with you a little bit more insights. And for sure, last but not least, I want to share a figure which might have changed because the slide is now also some weeks old, but we have above 50 implementation projects, and one of them we will also see a specific one today. So, said that, I would like to go quickly to share who we are. So, the Open Industry 4.0 Alliance is consisting of OEMs, of machine builders, component suppliers, software and application providers, system integrators, so quite a diverse group in order to have everybody on board to make the digitization for the members and the customers of the members as easy as possible. So we will see a little bit more on the next slide what I already said. So all our members are manufacturers or application providers, technology providers, system integrators, and we need that setup for the holistic and overall approach, which we also had at the very beginning. And sometimes people ask, why do we need an organization like the Open Industry 4.0 Alliance? So what is the specific of such an organization? So you see on the very left side that, and you know, a lot of standard organizations, standard bodies who are defining how the digitization, how the standards should look like. So what do we need as a standard in order to be successful? So this is a very important step. We see on the second and third step the big difference and the value of the Open Industry 4.0 Alliance. So we take existing standards and bring them to life. And we will see a little bit more about that later on. So we drive the adoption, we take the existing standards and perform implementation projects, as we said, as an implementation organization. So, and our members are then the ones who are implementing those solutions for their customers and drive the usage of the existing technologies. So I don't want to go into the deep details of the OI for reference architecture. So we will see that anyhow later on in an, let's say, real example, a little bit more detailed. But what I want to share with you is what I already said at the beginning. So there are standard organizations, there are other associations, and this is for sure not an overall picture, just to again show the positioning and the idea of the Open Industry 4.0 Alliance. So on the shop floor level, you see there are organizations like OPC, Profinet, Universal Automation Organization. So they are on a specific level, on a specific area active. On the right side, you see, for example, the Industrial Digital Twin Association, who are bridging, let's say, the level 2 and level 3 of a reference architecture. Or you see a Platform Industry 4.0, which is giving guidance for the overall IoT architecture. So all is relevant and needed, but somebody has also to have a look into the implementation, and as we usually say, from the shop floor to the top floor. So, and that is what we do in the Open Industry 4.0 Alliance, and why we have also this diverse setup, which I showed to you some minutes ago. So, and what do we do in the OI4 Alliance? So we have several work groups. We saw 17. You don't see here a number of 17 because there are some marketing and communication related work groups not listed here, but the core of the Alliance is in the technical areas. So we have technical work groups, and we have also the demand side, the customer facing side, the industry focused work groups. And we see also in the middle that there is an interaction between the technical and industry work groups. So what do we do in these work groups? We take care of the vertical and horizontal integration. These are words which most of you might have heard, but in very simple sentences. So there are different technology solutions or interfaces which are relevant for specific industries, and they can be used for the specific industries, target industries. So we have several work groups in the industry area, which are more in the process or in the discrete part of the organization. So we have also an overall work group. We will see a little bit more about that, which is taking care to consolidate use cases and prepare the solutions and projects for the specific markets. But we will see a little bit more about that as well. So horizontal and vertical integration, so technical integration, but also process integration, data integration is very important for us. So how do we do that? And this is also a snapshot, maybe 2 or 3 weeks old. So we saw the different pillars. We saw the technology area, where we have a so-called technical committee, and where we align the overall technical roadmaps, and also the OI4 reference architecture, which is, let's say, the frame where we are acting from a technical perspective. On the left side, we see the industry work groups, which is also
his microphone, or my microphone, is picking up what Ekrem is saying, and they get the rebound. You need to keep an eye on the screens as well.
Specific projects and activities towards the markets. And then on the very left, and on the supporting side, you see, as I mentioned before, we have 2 employees, the managing director and technical director, but we have also a service organization, which is orchestrating the members and the work groups and the work group leads. And we have also marketing and communication related activities. So all that is needed to be successful from a global perspective, from a holistic perspective. And for sure, as we also learned before, the digitization is not happening in a workshop. So we are going into implementation projects, we are going to facilities, and that is what we will hear in a few minutes more precise. So that is what our Open Industry 4.0 Alliance is standing for. And to make it very simple, sometimes people ask, what is the value of an OI4? We believe that with such an approach, we can become the USB of the factory for the industrial Internet of Things related activities. So today, it's very difficult for a company to know which standard, which interface should I take, and how does it, let's say, interact with other solutions in a multi-vendor approach. And that is exactly what Open Industry 4.0 Alliance is doing in the work groups and in the implementation project. So happy to hear now more details, what exactly happens in an implementation project, which smart solutions are the base for such implementations. And I would now hand over to Jules. Jules.
Thank you, Ekrem. Thank you, Ekrem, again for your introduction. I'm here in the studio, so we're making switches between multiple locations, and I need to watch up at the camera over there. Just checking if the sound is on. Sound is on. So we had some issues with the microphones, with the sound. If it continues, let us know, and we'll fix it. Now, before I start with my part of the presentation, let me ask you a question, an interaction that will pop up in your webinar screen to better understand where you are in integrating the data from the field, like Ekrem was just explaining. OI4, the Open Industry 4 Alliance, is an implementation alliance. We're applying standards that are or have been out there for a number of years, or in certain cases, like the asset administration shell, are quite new. So let me ask you how easy it is for you to integrate data from field devices for maintenance and optimization purposes, i.e. other than control and monitoring. So there should be multiple choices popping up for you at this point in time. And I'm just scrolling through the presentation here. There's some hiccup. So if the moderators can start the interaction, otherwise I'm going to skip it. Well, I'm looking here on multiple screens as don't see the feedback. So for some reason the interactions are not working. So let me start with my part of the presentation. And now the interactions are coming in. I can see them on the screen. There's some delay. There's about half a minute delay, making it a little bit difficult. But let me ask you again, how easy is it for you to integrate data from the field devices for maintenance and optimization purposes, i.e. other than for control and monitoring purposes? So have you integrated data from the field into asset management systems or other systems for optimization purposes? Are you finding it difficult to integrate data from the field? Are you finding it costly to integrate data from the field, or are you looking for ways to quite easily benefit from data that's already available in the field devices, diagnostic data that allows you to optimize your inspection maintenance programs? Or are you looking for support maybe in this as well, and information in this as well? So I'm looking at the responses. About 40% of you have integrated data from the field into asset management systems. A number of you are having difficulty integrating it. This is what we encounter also as well. It's about 20%. Some of you quite rightfully indicate that about 20% as well, that it is quite costly to integrate data from the field. And some of you are looking for ways to integrate data from the field in a better way, and looking for support. That's also about 20%. So about 40% already is at the stage where they're integrating data in the field. Thanks for your inputs. Now, let me go to the presentation, and let me first explain a little bit what UReason does and what motivates us. So today, a large proportion, 90% plus of the data from machines and processes is not used to optimize operations and maintenance. So sometimes it is unlocked from the field devices. In many cases, as we also just saw in the questions, the data is not unlocked. There are multiple reasons why. It's sometimes difficult. It's a different trade to actually get value from the data that is unlocked from the field. It requires another skill set, another set of tools, another type of motivation looking at the data, but also the data connectivity is very hard because there's many islands or silos where it's difficult to actually get information from one silo into the next and into the next. So it's one of the elements that we see quite a lot, which is prohibiting total integration, and it's prohibiting companies to do real-time condition monitoring, predictive maintenance on data that is already there. Plus, and this is something that we hope to take away in today's webinar as well, it's expensive. It takes a long time to develop solutions using the data from the field, because there's not a lot of implementation standards, implementation guidelines out there that help you in this area. And we hope that we can help you in this area a little bit also with the information in this webinar. Now let me explain. UReason is a software provider. So we provide a software which we see roughly in the middle of the screen there, APM-Studio. And APM-Studio is a tool suite that allows you to reason in real time on data that is unlocked from assets out there in the field, asset data from different PLC manufacturers, or asset data directly unlocking it from the assets out there in the field via hard interfaces, Profinet interfaces, Fieldbus interfaces, etc. Using edge hardware, we can do a lot of the heavy loading, a lot of the data analysis on the data close to the assets, i.e. close to where the data is generated, and then integrate that into cloud solutions. As a software provider, we play in the field of deploying our software APM-Studio at edge level, on-premise compute, but also at the cloud level. Now, UReason, actually all the parties in this webinar is a member of the Open Industry 4 Alliance. Why are we a member of the Open Industry 4 Alliance? Because it allows us to take our customers, our asset owners, but also our OEMs along a implementation path that is not convoluted, which uses standard publications, which is accepted by industry and which is supported by a large number of members of the Open Industry 4 Alliance. We take data from the field level. We take data from the field level in multiple different protocols, 4220 milliamp, IO-Link, Profinet, Profibus, but of course also Modbus, EtherCAT, and other connection protocols. And we've defined a reference architecture where at the edge level, so that could be in the cabinets or it could be on-premise where your SCADA data historians are located, at an edge level already some heavy loading, heavy processing on the data is being performed before it's communicated upwards, northbound in the cloud to cloud platforms that provide you with maintenance management functions, cloud platforms that allow you to benchmark performance of your assets across multiple sites, for example. And in the Open Industry 4 Alliance, we're an implementation alliance. We adopt standards. So we don't create standards, as Ekrem was already explaining, but we adopt standards and we provide guidelines for you customers, asset owners in industry, having a shop floor or having a process to rightfully adopt the different standards that are out there. Standards for doing Dockerized, containerized deployments of software, standards for communicating data from the shop floor northbound, standards for security, standards for sharing, for example, information about assets, like the asset administration shell, and standards for sharing data, which are in development by the Data Association, the ITSA. In the Open Industry 4 Alliance, we work on a number of different use cases. And today, also in today's webinar, but also in the live demonstration, we're going to show you a number of these in the live demo. The use cases are centered around master data management at the lowest level, automatic onboarding of assets in the automation pyramid and outside the automation pyramids, but also condition monitoring, predictive maintenance, and remote sensing are all part of this. The use cases where we have different user groups, as Ekrem already explained, for discrete, for logistics, for process industry, for pharma, etc., are focusing on realizing these use cases. These are the discrete and the process use cases that quite a large number of volunteers are working on to realize this, to actually show and help you how to implement these in the field. Now, you could continue doing things in the old-fashioned way with inspection rounds, listening to your assets, sensing your assets, so to say, taking into account what is happening out there in the field. But this is an approach where you need access to expertise, skills, and expertise, and to people, of course, that have this. It's from a safety point of view, especially if you need to do inspection rounds on telemetry, on instruments that are high up or in difficult places or in dangerous places. From a safety point of view, it's also a bit of a barrier getting there. In the old-fashioned way, doing your instrumentation inspections and relying on the frequent rounds of your field engineers doing this, you could be too early, which is not good because you're wasting money, wasting energy, or you could be too late, again, which is not good because you may be affecting the integrity of your assets to a too large degree, running into unsafe operations. And of course, wasting at the same time and energy, i.e. doing this in this old-fashioned, in the traditional way, let me put it this way. You have to travel, you have to be on site, it's difficult to remotely monitor, etc. So you may be not on time, maybe too late. It can be costly from a time and energy point of view. A different way is actually to use, and that's also what the Open Industry 4 Alliance propagates with its reference architecture, but to use already the data that's out there in the field and to automate your typical process in dealing with the data that's coming from the field a lot of the instruments and sensors and actuators that you have out there in the field already communicate diagnostic data. In certain cases, they already communicate any 107 events, which can be directly brought into your maintenance management systems for automating the tasks around equipment being out of spec, equipment requiring maintenance, or equipment indicating that they will fill at a certain point in time. At the same time, using the data, the additional data that is available out there in the field, you can set up condition-based and predictive maintenance programs which are data-based and can use algorithms to provide you with early indications, time to event, of when things could actually start failing, such that you waste a lot less energy in overhauling equipment that is in good working conditions. And using the OI4 guidelines, it's an integrated approach, so it allows you to easily integrate this into or next to your automation pyramid, which is also quite important. So the message that I want to share with you here today, and which I will also show you later on in the demonstration, is that you can automate a lot of the processes that you do today in a traditional way, saving on energy, saving on outages, and saving on cost, and scheduling your precious resources in a more ideal way. And at this point in time, I'm going to hand over to Eelco. And Eelco is going to walk into the screen. You can see we sit in the studio here. So now you can see both of us here.
Yeah.
And
so we can go to the next slide. Jules can be muted, so that helps. Let's go to the next slide. Yeah, okay, let's take this slide first, because I thought it was an interactive slide going in, but doesn't matter. We'll pick it up here. What is focus? And then I'm going to stand behind Jules. It's a little bit awkward, but this is going to go. I don't want to be in your screen field. Flow optimized control using sensors. Focus. That's actually what we're trying to realize. And I will go in a little bit deeper what the device is, but it's actually measuring and control. It monitors and diagnose, etc., and it looks very good. The key specifications of this device is a DN50, DN80, DN100. And you can use it for liquid applications in the process industry. So what is it? Well, in the basics, it is an integrated device. It's got flow, pressure, temperature sensors in there. It's got an actuator in there. It's got Wi-Fi in there. It's got a one button to control it all. And it's got a computer in there. So it's an interactive device integrating a lot of sensors and an actual actuator, a globe valve actuator. But why did we do this? Why did we integrate everything into one device? And well, the technology is right for it. Let's be honest. We all want OI4. We all want data coming out of our instruments and out of our field devices. But by having small computers like the compute model that we have right now, we can actually integrate them into our devices in the field. And with that, we're actually having so much computing power and so much storage for data that we can start capturing knowledge. And why do I say that? Well, we all know the great tsunami that is coming. We need to make sure that the data and the knowledge that they have is somewhere used. And we try to do that, to use that in our device. However, this makes our task a little bit difficult, because you can see what we have communicating with each other. It's a Linux operated system. We've got an asset management tool in there. We've got a UI software in there and a web server. We've got electronics, of course. We've got embedded coding. We've got a compute model in there. It all has to interact with each other. So we, as an instrument provider, developer, we had to learn a lot over the last few years just to make sure that we got the data here. But why do we do this for you? Why do we do this for our customers? We want to share our process insights, because when you have flow measurement, you've got pressure measurements upstream and downstream, and you've got temperature measurement upstream and downstream, we can start thinking about redundancy. Because there is a risk when you integrate all instruments in one device. What if one fails? I have to change the whole device. No, not in this case. Since we know what's happening within the device based on flow, based on upstream pressure, downstream pressure, and valve position, we can actually have a digital twin model in there which having soft sensor values. So if the flow value cuts out for whatever reason, there is too much gas content in the medium, it's still able to collect, hey, this should be the information that we communicate. If a pressure sensor fails, the model says, hey, I see that the P1 sensor, the upstream pressure sensor is failing. It should be this value. It's not just that. So this is looking at the mechanical workings of the device. But when we know a little bit more about the process, what's happening there. So we have the speed of sound of the ultrasonic transducers. We have the signal to noise ratio, we have gain values, and we've got all the other information there. We can actually calculate and show cavitation. And then it becomes a little bit more interesting for the process engineers and the process owners to see, hey, how well is my device doing? Is it cavitating? Is it wearing out? And why is it cavitating? Are my process conditions correct? So we get a lot more insight in the process, and we want to share that information. But then the question comes, how do we share that information? Well, by adapting the OI4 Alliance concepts, the strategy, and the software from the company UReason, we are actually now capable of getting all the data out of this device. So here you see our data coming into the device. This is actually the tool that's running on the device. So here you see all the sensor values coming in into the software. And based on all these data streams of that software, of the device, of the sensors, of the actuator, etc., we can define classes. And these classes represent a P&T sensor, or a flow measurement, or an actuator, or a positioner. And not only that, we can use those classes to build a complete model, the digital twin, of the device within the device. And that's very, very nice to have, because as an instrumentation company, we are not used to having to code so much software. With the technology that we have right now and the adaptance of the OI4 Alliance, we're actually capable of having physicists, in our case, do the modeling of the device and actually creating complete new devices. It becomes a complete flexible platform. And with that, we don't have just the dynamics of the device. We can also create situations or circumstances where we alarm on, or where we trigger on. Here you see a few alarms that we can give with our device. They actually are modeled and created within the software within the device. And here we see a whole inside of the device. This is actually the digital twin and the calculations of all the data streams. And this is the deepest level that I'm going to show you, where all the data is throwing from point to point, from class to class. And here is actually a lot of logic behind where we can say, hey, what's the actual pressure sensor value? What should it be? So that we can have redundancy, software redundancy on our values, on our sensor values. But it's not just that. It's not just configuring. It's not just creating models. What we have is actual interaction with the device. This is a typical flowchart that we use for auto-tuning in the process, because it's a valve, and the valve needs to be auto-tuned to make sure that it is working in the process. But this is actually a question and answering game, or flow, between the device and the customer. It's very easy to use on the web server, so you can see exactly what's happening. But the logic is the same. Physicists can do the intelligence of the device in our case. And it might be that in the future we also need chemists or biologists, so that we have different knowledge coming from the device. Because we are ready for new insights. We can now think, because of the computing power that we have on board, we can start thinking about, do we want to control centrally or locally? Because we already have PID tuning in there. So you can also say, hey, do I want to control flow, or do I want to control on valve position? It makes it easy to implement. And Foundation Fieldbus tried it so many years ago to have decentralized control, but it proved to be very, very difficult to implement. It was very difficult knowledge to understand. So your control systems can become quicker and easier and cheaper, but also more accurate. So you can start thinking differently on how to implement such devices into your process. But there is way more in there, and we're just starting skimming the surface of what's possible. Jules will show it you a little bit later in the demo. We're currently working on density measurement. It's not out there yet, it's still in beta version, but based on all the information that we get from the device, we have a pretty good feeling on the density measurement. but there could be much, much more. Let's see what we can do. But for that, we need to unlock the device data, the loop data, the plant data, and beyond, because we need to connect everything and it needs to be open. That's at least our philosophy. That can only be done when you do it secure. So that's the reason why you also have that button. That button gives you control. Who is accessing the device via Wi-Fi or via Ethernet? And that's the first level that we have on security. The second level is that we have actually users and user roles defined within the software. So your admin is actually capable of saying that person is allowed to work with it, that person is allowed with it, and he is allowed to do that, and he is allowed to do that. So we have those user roles and passwords in there. That's our way of making this device secure and making it capable to operate in a safe environment like the process industry. That's the last slide that I have to share with you. And I would like now to give the rest of the presentation to Jules, where he's actually going to show a demo on how it's working at the duurzaamheidsfabriek.
Hi guys, if I can get the controller actually for 1 second, or I have a backup here as well. Let me make this screen a little bit larger so you can see it. I need to hide this one. So I'm sharing my screen. This is a studio setup that is quite nice, quite complex, also with 4 parties. This is the live demonstration I want to show you. Before I'm going to show you, I'll first explain the different parts and be aware, please note that the certain screenshots of the demonstration are also included in the handouts that you'll get after this webinar. So what I'm first going to show is this little ball, and I'm just trying to see if my mouse is there. There you go. Which is at the device level. Eelco just talked about the Focus One device. We're going to have a look inside the Focus One device to see what type of data is available there at high frequency. Then we're going to look at other devices, predominantly 4 to 20 milliamp hard devices that are in the section of a flow loop that is part of a processing facility that's not too far away from the location that we're currently at. And we'll actually ask the owner of a flow loop to create some flow. So we should also see flow appearing after a few seconds. Then we're going to have a look at the remote I/O gateways from Pepperl and Fuchs, where we are unlocking data via hard, but also data via I/O link. Then we'll have a look at the OI4 OEC. OEC stands for Open Edge Computing. OA4 is Open Industry 4 Alliance, of course. It's a broker that consumes and publishes the data that comes from the field to other types of applications. And then we'll have a look at how you can actually use the data that comes from the field to generate, for example, work orders. And to show this, we'll highlight some of the analytics inside APM-Studio, and then work order generation, which is done automatically on the basis of field data in a system called Ultimo, one of the CMMS systems that's out there. All of this is shown in a live demo. So what I'm going to do is I'm going to minimize this screen, and step by step I'm going to take you through parts of the demo. So let me start. Let me start by first having a look here at this screen. This is the Focus One device, one of the Focus One devices that is out there in the flow center, in the sustainability factory, which in Dutch is duurzaamheidsfabriek. And we can see currently that there is no flow, and I'm going to look here at the moderators to see if we can ask Huub to start generating some flow. So we can see there is no flow at the moment.
No, Huub, are you okay to start the flow loop, Huub?
I think he will. He probably picked up on that message. If not, we'll give him a call. But let's see how we can see the flow going up here. We have within seconds 16 cubes an hour. Thanks, Huub, for doing that. The Focus One device allows a field service engineer at the device with a Wi-Fi connection over Bluetooth to communicate with the device, to download logs from the device, investigate the alarms, make configuration settings if those configuration settings need to be made out there in the field. And inside the device, and have a look here at this address. So this is one of the devices that I'm now going to access, but on board, i.e. internally, one of the Dockers running there. Inside the device, we are getting, and we see volume flow here going quite high, 16 cubes an hour at the moment. Inside the device, there is high frequency data, roughly at 66 hertz, providing all kinds of aspects of the flow control valve, the Samsung flow control valve, of the volume flow, of the pressure, of the temperature. And as Eelco already explained, behind here is an entire software system, the software system that is actually doing a lot of processing on, for example, the different states in which the equipment is, but also at a very high level, of course, the current mode that the device is in. So it's currently in normal mode. It's operating normally. But also, different rules, different processing rules that allow Focus One, the company, to do different determinations to determine if there's flashing, cavitation going on, determining the wear and tear of the plugs, but also, for example, as Eelco was explaining earlier on, doing PID optimizations and PID control locally at the loop. Now, I'm going to make a step to the Rio gateway of Pepperell and Fuchs. Here we see data. I'm not going to refresh this screen, but believe me, there's flowing data here as well. Here we see data coming straight from the Rio gateway from Pepperell and Fuchs. In this case, there's actually next to the Rio gateway also an IO link interface. And there we get acceleration data directly from the flow loop, which is relative to a number of sensors that have been placed near rotating equipment. Again, here it's raw data. You need to process this raw data in order to make sense of it. And to make sense of it, we communicate the data up to level 3 here, at 0.3 here, not level 3, 0.3, which is the OI4 OEC broker. And let me share this broker with you. So the OEC broker is an MQTT broker that receives, as we can see here, different data streams from different instruments that are out there and switched on in the loop, providing flow speed, valve positions, volume flow, etc. And let's have a look at one of these messages. We can see, and hopefully you can see this as well, a continuous update at quite a rapid rate of the volume flow. The payload is a volume flow, indicating that it's varying over time, but also the signal to noise ratio, the electronics temperature of the actual control valve, and many, many more properties. All this data is actually being communicated. So I'm going to switch back again from, in this case, the Focus One device via a Open Industry 4 compliant, OEC compliant communication broker. So we see that this data is currently communicated from the Focus One device. And if I look at the data source settings, it instructs the valve, in this case, what port to communicate to. And it instructs it about serial numbers and a number of other things. We don't have the MAM, which is the Asset Administration Shell, in here yet. We're also starting to implement that, such that the devices can also, in a plug-and-play fashion, instruct what capabilities they have and how you would like to, or how you can integrate those to other devices out there in the field. And then at the edge level, so we have a, I didn't open that one up yet, but let me do that very quickly. Let's give me a second. It should be in the 13 range as well. This guy. At the edge level, so we're running, as you saw in the picture earlier on, a Wago Edge computer. And I'm logging into the Wago Edge computer here. On the Wago Edge, we can see, let me zoom in a little bit for you. We can see there's 9 running containers, and the containers are all healthy. These containers are Dockerized components that provide, for example, an OI4 registry, what is running out there in the field, what capabilities do they provide. It's running an APM-Studio instance for doing edge analytics. It's running an OPC UA connector from M&M software. It's running a Wago connector to allow also the data to be communicated northbound up to the cloud, to the Wago cloud. And in addition to that, it could also run Azure connectors, AWS connectors, etc. Here we here we follow the Open Industry 4 Alliance publications that are based on standards, but are very much focused on the implementation side of things. So one of the containers here is this APM container on the Wire Edge device. And this is the actual container here that we're looking at. The Focus One device currently does not have any active alarms. So we did have earlier on active alarms which were related to having no flow at a certain point in time, which were put in just for illustration purposes. But from time to time there are issues with the supply pressure, the air pressure to the control valve to the Focus One device. And from time to time, that requires an action from a field service engineer to go and inspect and see what's actually going on. The device is constantly receiving data. I'm doing an update here on the data stream. It's constantly receiving data over the wire for volume flow, pressures, temperatures, the gain, signal to noise ratio, etc. And it provides a pretty clear overview either to an asset manager or an instrumentation engineer as to what the now current values are. Now within APM-Studio, we've also set up specific rules next to the dashboards. We set up specific rules that will automatically, as and when required, generate, and that's the last part in this demo, automatically generate work orders. So from the edge level in a secure fashion, transmit work orders related to field equipment that's out there in the field. So instead of you in a traditional way having to go out and inspect the devices, work orders are generated on the fly. Here we see one of them that was generated yesterday, actually, to be very precise. And it's automatically generating these work orders on the basis of the diagnostics that are done at the edge level, on the basis of different issues that are being detected at the device level. And you can do this for a Focus One device, but you can also do this for any of the field devices that are communicating using the same OA4 OEC publications that are using either Profinet, Profibus, 4020 milliamp HART, IO-Link, etc. You can basically automate the work processes of inspecting and safeguarding, monitoring your asset base, supporting your processes in a very efficient way. Automating that processes, saving on energy, reducing the number of outages, knowing about issues early up front, but yeah, also taking into account the ways in which, of course, the assets are being used and utilized out there in the field. And that in a very short fashion, and I'm looking at the time, I'm right on time. We have about 15 minutes left for the Q&A session. That concludes the demo. If you are interested to get additional insights, I had limited time here, but if you want to have additional insights into the demo, into the setup, don't hesitate to contact us, Ekrem, Eelco standing behind me now again, or myself, of course, or any of the moderators. Don't hesitate. There's a lot more to show, but we only have limited time here. So let me now hand over back to the moderators and to the stream of data. And Huub, I would like to thank you for generating the flow. That worked quite nicely with all the technology that we're using. And let us have a look at the questions. There's a question to the moderators if they can make it a little bit larger, because my eyes are...
We're getting old.
Not that young anymore.
For Jules.
There's a question by Jos. In the reference architecture, there's mention of MQTT. What about OpenC UA? A very valid question, Jos. So in the OEC publication of the Open Industry 4 Alliance, MQTT is used as a transport between the field and edge devices. OpenC UA, if you go towards secure communications, if you need to do a protocol switch, OpenC UA is also supported, but it's also notably true that the message content, the payload that we embed in the OA4 OEC data that is published is OPC UA Part 100 compliant. So OPC UA is being used also in the demonstration architecture that I showed earlier on. You saw that OPC UA is actually one of the data providers in the total reference architecture. So we also support this. And going on to the next question, and you see me squeezing maybe with my eyes, a question from Athena. How can we deal with various devices that are already available in the market operating at different standards and equipment compatibility? That's a very good question, Athena. So in the demonstrator that we showed earlier on, we actually have a number of devices, also old devices communicating, for example, only Hard 5, but devices communicating Hard 7, devices from Emerson Corporation, devices from Honeywell, which are not OI4 members, just to make that clear. Devices from Econosto, but also devices from Endres and Hauser, from Krone, from Samsung, from Focus One. We have a multitude of different devices, i.e. a multitude of different vendors, for which we can adopt quite easily the examples that we just showed. So data from devices from a multitude of different devices out there in the field can easily be extracted and in a standard way be extracted and communicated to edge compute northbound. So equipment compatibility and communication protocol compatibility is one of the things that we've taken care of in the publications and also in the work that we do. And actually the OI4 demonstrator that we showed earlier on is actually proof of that it's working for a multitude of different vendors and a multitude of different ages of equipment.
Yep. So I hope my mic is on so that people can hear me as well. Yeah. For Eelco, by Torsten, what's the required straight pipe length for up or downstream? Yeah, good question. It remains to be a field instrument, so we have some requirements there. By the way, we communicated all the fancy protocols, OPC UA, MQTT, etc., but it still can operate with 4 to 20 milliamps hard. It has an input, it has an output. We can communicate also at a very basic level within your process. That being said, the inlet length needed for Focus One to have optimal performance is 4D. So that's relatively limited. It's very low, and 0D after. You could even operate it in a 0D application, but then your accuracy will go down a little bit. As you go up to at least 5% accuracy on flow measurement. But it is a flexible device, and it has to do with the fact that we have squeezed the ultrasonic transducers in such a small area, and we increase the path lengths of the transducers so much by having it bouncing and back into the body. So we're actually capable of having those transducers very close to a valve, which is normally not supported in the process industry. Then the second question is by Alfred. Is it possible to install Focus One in a vertical pipeline? Yes. No worries there. It's acting like a normal valve or a normal flow meter or a normal pressure sensor. It doesn't matter if you put it horizontally or vertically. Then the next question is for Jules by Stefan. You can take over.
Yeah. Is it possible to install a second temperature sensor? And if yes, is it possible to calculate the heat consumption in kilowatt hours? And is it planned to achieve a MID, which is a measuring instrument directive? I think it's a question for Eelco, actually.
One from me.
Yeah.
I love the way you think, Stefan. This is an interesting one. We're actually continuously developing, and we see the future possibilities of this device. And indeed, energy measurement is one of them. For that, we need a separate temperature sensor input. So we are working actually on the next development to have an extra analog input so that you can directly connect a temperature sensor in there. We don't have that yet. But let's be said, for MID certifications, you have quite high certifications. So the heat measurement we can actually calculate it. But I think for flow, we're roughly about plus or minus a % on the flow accuracy. So we have to find and reevaluate the standards, especially for the heat measurement, if that's enough for calculating energy. But a good question, and it gives you indeed the flexibility that we're trying to go for with the Focus device. Thank you for that.
Then the next for Ekrem.
for Jules, I see.
No, I think the moderator is highlighting
okay, Ekrem.
Ekrem.
Yeah. What? So sorry, I will tell it to you, Ekrem. What's the value of the OI4 Alliance compared to the other standard bodies?
Yeah, that's a valid question. So as we are not a standard body, we take care of the how to implement. So, and also how to integrate from the sensor to the edge, from the edge to the cloud, from the cloud to the application, from the cloud to the ERP, from the cloud to the MES. So because you have to integrate all what we saw today in your landscape, not only on one level, on all levels, and that how to in this ecosystem and also in a multi-vendor approach, that is the big value for OI4 members and customers who work together with OI4 members.
Okay, thank you, Ekrem. Then the next one is also for you. How much time does a member company invest in the OI4 activities?
Yeah, that is usually the question which is asked when companies start to think about joining the alliance. So there is a very simple answer. If you have people who work actively in the technical or industry work groups, then you need in an average 1 day per week distributed along different people. So roughly 20% capacity. And usually the more important answer to that is you are not going to do something completely out of your daily business. So if you are anyhow a system engineer and you integrate XYZ, then you go to the right work group so that you benefit from your daily business and the fitting technical groups or the fitting industry groups. Yeah.
Okay, thank you, Ekrem. The next question is for Eelco. Does the valve dimensions keep the ANSI standard? Simple answer, yes. DIN or ANSI, you can have both. Then the next one is for Jules.
Yeah, actually there's a number of them. We have 5 minutes, okay. By Philippe. Philippe was making a remark about that there is a lot of data from one device in a simple application, and how do you integrate a complete major portion of a process plant? Very valid question. So what we showed was an edge computer that is in a number of playing a role in a number of control loops at the flow center. Connected to about, in total on all the sections, about 100 devices. And if you would like to scale this up to a unit plant level, etc., because this is at a unit level, what you have two approaches. So at a unit level, you either deploy edge compute, and the edge compute takes care of the heavy loading on high frequency data if and when available, and doing the diagnostics local on premise. And edge compute can be virtual or physical edge compute in this case. So virtual edge compute, for example, with Azure IoT Edge. If you would like to roll this out across an entire process plant, then you would basically do this. I would recommend to do this step by step. So go for the critical units with the critical process equipment first, and then do it step by step, either applying physical or virtual edge compute in the same fashion. The reason why we have this step in between, you don't want to bring all the data from the field to the cloud, because that can be quite costly, especially when it comes down to high frequency data. So you need to do some of the processing at a lower tier in your automation pyramid. And then it can either stay within the automation pyramid, or it can go outside the automation pyramid in a NOAA type fashion. And a question about digital twinning by Carl. Are there clear cases where digital twinning was delivered, or has delivered, benefits? Yes. I think that there are actually multiple cases where digital twinning has delivered benefits. So digital twinning is more than having PDF documents of your asset. What Eelco showed earlier on in the presentation is actually a digital twin model where soft sensors take over as and when a pressure, temperature transmitters, or other important parts of the electronics of the Focus One device are failing. But you can also apply high fidelity type simulation models at the edge level, for example, to keep an eye on how your process should be running under the given conditions. And yeah, we have multiple examples of that on turbines, on compressors, on different type of equipment where digital twin models have delivered great benefits.
Yeah, and maybe we can, for the last question, we can go to the last one. That one, yeah, that's one for us actually, Jules. That's maybe a good ender. It's from Manfred. Can you say something about the lifetime of the sensors that you use? Is preventive maintenance of the sensors and or technology? I expect that he is asking if we can do predictive maintenance on these sensors, and if part of the technology is. I'd love to. Don't get me wrong. We have this device now out for a year in the field, and to be able to do predictive maintenance on sensors, we need a little bit more data. So it's always the chicken and the egg discussion that we have right here. We actually now make sure that we have all the data, not just the internal diagnostics data of the flow measurement, but also of the P&T sensors. And over time, we need to aggregate that data and analyze that data. But that's also the reason why we chose for the solution that we have in the device right now, because that functionality is in there. And trust me, if we find the keys for unlocking the data, and I'm not talking just about a valve level, but let's integrate a pump, let's integrate flow measurement, let's integrate pH sensors, let's integrate everything that's needed in a process plant. Then you start actually picking the low-hanging fruit. Maybe not even low-hanging fruit, you're slipping over it because there is so much value still in there. But before you can reach that, you have to unlock all the devices and get the data coming out. And trust me, data is not yet information. So we have the data right now. We can say something about failing sensors and get soft sensors values back so that your process doesn't stop, but that you can keep on going. The density measurement is an extra sensor that we got. We found it, and hey, look, it's there. It's completely new within the organization that we have right now with flow measurement, pressure and temperature and valve position. But yeah, there might be much more in that. And I would like to go to predictive maintenance of sensors that the sensor itself says, okay, hey, there's something here over time, or the combination of sensors that says there's something happening here over time, and we trigger an alarm. So I think that was the last question. I don't see anyone questions anymore. We're very good on time. And I would like to, and I don't want to stand into the face of from Ekrem, so sorry. So I'd like to thank everybody for listening and putting up with some great questions. Thank you very much. Ekrem, Jules, thank you very much for participating in this. I love this cooperation between the three of us. Let's go for open data sharing and make it possible that we can connect everything also with our customers. Thank you very much for your time.
Thank you, gentlemen. Thank you all.
Thank you all.
Bye-bye.